In this video, we're going to review some of the statistical methods that are available for you to perform on your Pandas data frame. This includes sorting values, finding correlations, summarizing data, and also filtering data. If you find this video useful, please give it a thumbs up and also consider subscribing to the channel. We're going to begin by importing NumPy and Pandas into our workbook as PD and NP. I have a CSV file called movies.csv that contains information about popular films, their revenue and internet reviews that I will be using for demonstration, and you can head to the GitHub link in the description for access to the file so you can follow along. I'll start by reading in the CSV file into a data frame, and I'm going to call this movies, and we can see that we have 76 rows of data on the film, genre, audience scores and profitability. We're going to begin by sorting our data, and we can do that with the built-in function sort_values. This takes in a string for the field that we want to sort on. So for this, I'll use the audience score. And then by default, it will use an ascending order. So we can see the first film has the lowest value. However, we can make it descending by passing in a second argument to sort_values, and this is going to be called ascending, and then I'm going to make this equal to false. If we want to sort on multiple columns, we can pass in an array of columns. So I will first sort on the audience score, then on the Rotten Tomatoes score, and both of these are going to be descending. However, if I want to mix up the order, I could pass in an array to the ascending argument to sort the first value as descending, so I'm going to put false, and then if I want the Rotten Tomatoes score to be ascending, I can put comma and then true. So what we can see is that the audience score is sorted first for the highest, then the Rotten Tomatoes score is first for the lowest, as we can see for the row of 89%. We can find the min or the max value for any given column by passing in the column to squared brackets and then using the max method, which is built in. So from our data, we can see that the max worldwide gross is 709.82. And then we can find the index for this record with IDX max. So this tells us that the movie with worldwide gross, which is of a maximum value of 709.82, is at the index position of 13. So if we want to know which film this is, we can then use the iloc method to find the row, and we can see that it's a Twilight film. An alternative way, and a little bit easier way, is that we can just pass in the IDX max function itself into the iloc method, and then straight away we can get that row from a single line of code. The same also applies for min, where we can find the lowest gross, which has just 0.03. We can find the index for this film with IDX min, and this is telling us it's at number 7. And then iloc for number 7 will give us that row, and that's waiting for forever. So our data contains quite a few numerical fields, and we may begin to wonder, how are they correlated? So correlation tells us the extent to which two variables are related in a linear way. So as one increases, how does the other column respond? So does it also increase or does it decrease? And also to what degree? There's quite a handy method for building a correlation matrix, which is core, so C-O-R-R. And if I run this on movies, so first we can see that we have an error, and we can see that because not all of our fields within our data frame are numerical. So the film name, that can't really be correlated with anything. So to work around this error, what we can do is specify an argument called numeric_only, and if I make that equal to true, this will ensure only numerical values are being included with our correlation. So in our matrix, we can see all the columns across the top and also across the side. And if we follow along the top, we can see the audience score has a perfect correlation with itself of 1. And this kind of makes sense because they're the same value. So as audience score goes up, the same value for audience score is going to go up in the exact same way. However, if we follow along this row for audience score, we can see it has a slight positive correlation with profitability, a strong relationship with the Rotten Tomatoes percentage, and also a positive but less strong relationship with worldwide gross. So from a very high level, this tells us that there is a correlation between the profitability and with the audience score and the Rotten Tomatoes percentage scores. This doesn't necessarily mean that there is a causality between the two, but there is some sort of linear relationship. As one goes up, we can also see the other one going up. So the matrix is symmetrical, meaning the top row is equal to the first column, and so on for all the columns. A negative value within this matrix would tell us that there is an inverse relationship between the two columns. So that means that one of the columns, as that goes up, the other column tends to decrease. So what is interesting from this matrix is that the correlation suggests that as years have gone up, so as years have gone by, the performance scores for all films gradually decrease. Now this doesn't suggest that as years go by it's causing the scores to go down, but it's just pointing out a potential relationship amongst these columns. So as we move past correlation, we'll begin to look at convenient summaries of our data with built-in functions from Pandas. So we have the value underscore counts method, which will tell you a number of occurrences of data within a column. So I will select genre and then perform value underscore counts. And this will tell us all of the values that we have and how many times that they occur. We can obtain the list of unique values within a column with unique, and the number of unique columns with n unique. So this will tell us how many unique values we have within a column. So from actually running these methods, I noticed that in the genre column there's quite a few spellings of the same word, such as romance and comedy, and also a couple typos. So if we want to replace all values in a column, we can do so with the replace function. I'll specify the value to replace as comd, so C-O-M-D-Y, because some of the columns have comd rather than comedy. And then the replacement value will be comedy with an E. Note that this is not made in place when we run this, so we would want to equate the column to our replace function. And what we also notice that there are multiple replacements needed. So we also have romance with a lowercase r. And if we want to make multiple replacements, what we can do is pass in an array of values that we want to be checked for, and then a second array of values that we want to replace with. And what we want to do is make sure that the order of the values that are being checked for are also in the same order that they're being replaced with. Now, if I perform a value counts on genre, we can see just 6 unique values and the counts have all been updated. So an alternative approach for replacing multiple values is to define a dictionary of replacements and to pass that into the replace method. So I'll have the key as the word which is being searched for, and then the value as what we want to replace it with. So in this section we're going to begin looking at filtering data. So in my last video we looked at filtering against booleans. However, we can also use some inbuilt functions to pull values between a given range for numerical fields. So if we wanted all the audience scores, let's say between 40 and 50, we can use the between method, passing in these two values to return a series of booleans for each row as they evaluate to our arguments. So I can then pass this series into the movie's data frame to filter it accordingly, and now we can see all the audience scores sit between 40 and 50. We can filter our data frame for the n largest number of values for a given column, so I'll use n largest function, and let's say I wanted the top 10 values for the largest audience scores, so I'll pass in the number 10 audience scores as the second argument. I can then change these values to return different numbers and also for different columns, so do feel free to have a play about with this n largest method. And then this also works for n smallest to return the rows with the smallest values. So to conclude this video, we can also take a look at how you can select random samples of your data. We can do this for an absolute number of values with movies.sample, passing in, let's say, the number 5, and this will just give us 5 random rows, and we can rerun this to see different rows each time. Alternatively, if you'd like a percentage of rows from your data, you can pass in an argument as a fraction and then specify the percentage of rows that you would like back. So for me, I would like, let's say, 4%, so I can do 0.04, and this is going to be giving us 3 rows back. So that concludes this video on some of the common statistical functions that can be performed on a Pandas data frame. Stay tuned for my next video, which will look at combining data with Pandas.